Hello and welcome to Electro Study YouTube channel. In this session, we are going to discuss important concept on network analysis. There are 5 questions and the topic which need to be covered. Number one, you need to understand what is independent voltage source and current source. Then basic information about filters. And I have already covered transient response of DC network and resonance in the previous session. Those who haven't watched the previous session so far, kindly check the previous link. It's available on the I button and the description box. Before beginning the session, I request everyone to subscribe our channel and support us. First of all, I'll be discussing about what do you mean by independent voltage source. So moving on to the brief information about independent voltage source. So you can note down what is an independent voltage source. Independent. 1 minute. So you have to write it properly. Importance of independent voltage source. So in case of independent voltage source, the constant voltage across the terminals are available. Voltage across two terminals will be constant. Then here, if you talk about the characteristics, so I'm going to plot the voltage versus current characteristics. Here voltage remains same. Let me say Vs. This is a constant voltage which is available. Also, the internal resistance of the independent voltage source that is equal to 0. So please note down internal resistance of an independent voltage source equal to 0. This is very important point. You can expect the direct question in the competitive examination. If I talk about independent current source, okay, independent current source. Here, the constant current produces at the input side. Also, the internal resistance of independent current source that is equal to infinity. This is very essential for your competitive examination point of view. Okay, so if I plot the graph, suppose if I am going to plot the graph of independent current source, I can mark like this. This is your, because current remains same, the source resistance or internal resistance that becomes infinity. Now let us recall something about filters. Anyway, you must have, whenever you are studying the rectifier, you have used one capacitor filter. Why filter is required? What is the purpose of filter? Anyway, application of filter in rectifier to remove the ripple content. Correct, no? That is actually a purpose of filter in case of rectifier. Likewise, there are two types of filters are available. Filters can be divided into two types. Number one, passive filters. Passive filters. Another one is active filters. So in case of passive filters, R, L and C components are used. It is suitable for high frequency application, usually in the range of 100 Hertz to 300 megahertz. Similarly, if I talk about the active filter, use of transistors, linear ICs like op-amp, operational amplifiers, etc. are employed in active filters. It is suitable for low frequency application. Okay, these are the differences between passive filter and active filter. All right. Also, you need to understand about what is a cutoff frequency. cutoff frequency. Okay, here you need to understand a specified parameter as 3 decibel. Okay, this 3 decibel range, that is known as cutoff frequency. It specifies a certain range after that 3 dB, 3 decibel. So these are the basic information I just want to inform you. Hope you have noted down. Now let us move on to the discussion. So first question. Here I will be drawing one diagram related to first question. Okay, let me draw the diagram. The time constant of the network you are supposed to calculate. So given network, so we have a DC source having voltage of 20 volt. There is a switch. Okay, it has two conditions, on and off condition. So we have one resistor. Similarly, one resistor and capacitor. So please copy the diagram. At least you can listen. This is 2R. This must be C. This is R. So the time constant of the network shown in figure. So you know what is time constant. Anyway, time constant, you know, tau is equal to R into C, right? RC, that is general equation. This is general equation, R into C. Here, when the switch is closed, if the switch is closed, what is going to happen? What about the value of resistance here? The internal resistance. If the switch is closed, let us consider when the switch is closed means the internal resistance also become 0. We consider R is equal to 0. Internal resistance of the source becomes 0. Now I'll be drawing like this. Here we have R. You don't mark anything here. Now we can draw the remaining part. 2R. Then this is your capacitor. No change in the value of capacitor. Now we have to calculate the value of resistance. Okay. Now what you can do is, now consider what's the total resistance you can calculate it. Here R and 2R will be parallel. No, here there is no source. So R and 2R is parallel. So R equivalent you can calculate it. R into 2R by R plus 2R. That is nothing but 2R square divided by 3R. Then R and R get cancelled. This is 2 by 3 R. So what is the equation? Please recall time constant of a given DC circuit. Whenever it comes to transient analysis, we are using the time constant tau is equal to R into C. Therefore, tau is equal to R into C. That is 2 by 3 R into C. So 2 by 3 R into C. Okay. So the right answer is, check the answer. 2RC is not the one. 3RC. No. RC by 2. So this is also not correct. C. Go for none of this. The right answer is 2 by 3 RC. I think you got the point. So like that, you can expect some questions in your GATE examination, or if you are going for the competitive examination, especially BSNL. Okay. Such kind of questions can be expected for those competitive examination. Make a note of this. So do understand what is time constant and how to solve the resistance, all those things. Now let us consider another circuit. So let me draw another circuit. So we have a DC supply, 60 volt. Next, we require one switch. It has two conditions. Now there is a resistor, then inductor. Everything is given clearly. 15 Henry, correct? Here 30 ohm. This is a switch, right? Okay, 60 volt. A series RL circuit with resistance 30 ohm and inductor 15 Henry has a constant voltage of 60 volt applied at t is equal to 0 as shown in the figure. Determine when the current at 0 plus. Okay. So what is the current? What is the value of current? Now tell me what is the value of current. So at this condition, especially when t is equal to 0 plus, that means, see, actually the current value that become the value of current at this condition, that is equal to 0. So can select the right answer as 0 for this condition. For this transient condition, the value of current that is equal to 0. Current is tending towards 0. Okay, because the inductor prevent changes in current. In RC circuit, when the switch is closed, the response, what about the response? So obviously, look at the RC network. Okay, you have to consider what is RC network. You should know when the switch is on and when the switch is off. Please recall the concept which you discussed in the last session. Okay, then come back to the answer. Yes, here, when the switch is closed, that means the response, that is decay with respect to time, because voltage is the variable. No, the switch is closing means voltage, the value of voltage that is coming down, because shorting, no, closed means the voltage comes down. The internal resistance of ideal voltage source. So internal resistance of ideal voltage source is equal to 0. Same thing we applied over the first problem. I think you are remembering. Similarly, another important question. The internal resistance of ideal current source, that is equal to infinity. So please answer option B. So these are the 5 questions which we have discussed in this session. I request everyone to like, share, comment to our video. Suppose if the channel is useful to everyone, kindly subscribe, kindly share with your friends and colleagues. Finally, thank you so much for watching this video and support us. Have a happy learning.